So over the past 29 years in the Big Bend region, we've lost about 66% of oyster reef area, which mirrors losses happening in shellfish habitats around the globe. Researchers, including many here at UF and in my department, have pointed to predation, harvest, disease, and changes in the timing and quantity of freshwater flow as potential drivers behind these losses. An additional stressor, which has received less attention than the ones mentioned on the previous slide, is wave energy. Obviously, wind and boat wakes, sorry, I lost my train of thought. Obviously, wind and boat wakes are common occurrences around intertidal oyster habitats, and wave energy is frequently called out as a factor which may exacerbate reef decline. Waves and strong hydrodynamic forces can disturb and move sediment and oyster shells, including the live oysters which may be attached to the shells. For example, in the Indian River Lagoon, boat wakes have been found to create dead margins or mounds of shell which are washed up on the reef above the waterline and subsequently experience reduced oyster survival. And one example of an attempt to quantify wave energy and its impact on oyster habitats was in North Carolina, where researchers used hindcasted models. And based on these models, the authors estimated that reef formation typically did not occur at wave energy levels above 500 joules per square meter. However, it's important to note that no wave data were actually collected at any of their sites, which is not uncommon due to the high cost of typical wave gauges. So if waves and boat wakes can cause shells to move, I started wondering about what I call oyster clumps. I've heard other people call them clusters, and the role that wave energy might play both in their formation and their fate. So this photo is from Corrigan's Reef in Cedar Key, and it shows kind of a reef platform surrounded by clumps. And I don't have time to get into it this morning, but in one of my other dissertation chapters, I have shown that clumps can move more than 50 meters when they're set out on intertidal bars like this, meaning wave energy is certainly playing a role in shaping these oyster systems. I therefore thought it might be interesting to determine whether there is a relationship between habitat contiguity and wave energy. So obviously, oyster habitats are not monolithic, but rather exist along a spectrum of contiguity. So the really classic reefs are those which are essentially uniform, continuous live oyster coverage, like on the left. And then as oyster biomass declines, so does the contiguity, meaning we end up with habitats like the middle, which are kind of separated by culch or mud, and then situations like on the far right, where there's really only just remnant oyster biomass remaining. And as I'm sure everyone is painfully aware, as oyster habitats become less contiguous, monitoring them becomes more challenging, and habitats like those in the middle and on the right may not be included in mapping or inventory efforts at all. So why am I here? Briefly, the questions that I am hoping to answer with this project, I think really closely align with the FORS mission, while also building on the Oyster Integrated Mapping and Monitoring Program. And I actually used the WIMP oyster beds layer and several of their reports to help me identify potential sites for this project. And I've really enjoyed learning about that program since starting at UF. Now, knowing that so much excellent work has already been done on identifying and inventorying oysters in this region, I thought about ways that I could build on WIMP while also collecting data on the drivers which we think are dictating oyster persistence in this region. So specifically, I wanted to develop a method to provide additional information about the sites which we see in the oyster beds layer, and to make this information useful to managers and folks like you all. So essentially, once we know that an oyster habitat exists and it has been ground truthed, I thought about what other information we could get from it somewhat easily. I wanted this method to be relatively non-destructive, relatively quick, and ideally repeatable, because again, thinking about the workloads of the folks who do this sort of monitoring work, they really need a way to track habitats through time as they respond to changes like harvest and restoration. So I put together a pretty challenging wish list for myself here. And much like the FORS mapping subcommittee, this wish list led me down the road of drone mapping and structure from motion analysis. I grabbed this table from the 2023 mapping report because it highlighted exactly what I hoped to do in this project, even including a little shout out for the oyster clumps that I described a few slides back. So bringing all of those threads together in this project, I am asking, how do oyster density and size class structure differ among habitats which are subjected to different harvest regimes, freshwater influence, and wave energy? And this study is taking the form of a survey in which I'm collecting data at 20 oyster sites in and around Cedar Key, Florida. And these key data are in situ site-specific wave energy profiles and RGB drone imagery at each site. So in May 2023, I identified these 20 sites, which varied in their harvest status, distance from the Suwannee River, and hypothesized wave exposure. And wave exposure was mostly determined by fetch, so the unobstructed distance over which wind waves can travel. And then this led to two general groupings, with the shell mound sites in the north lying much closer to the Suwannee River, which is the main source of fresh water in this region, meaning the waters there are relatively more fresh than the ones in the East Cedar Key grouping. I then built DIY wave pressure gauges following the design pioneered by researchers at Mississippi State. And between July 2023 and last month, I completed 3 deployments at each of my sites. And next, I am collecting drone imagery at each site using an Anafi USA drone. Each of these flights is occurring at an altitude of 25 meters with front and side overlaps of 80% and 75%, with a goal ground sampling distance of 0.7 centimeters per pixel, so pretty high resolution. I am then using structure from motion to create digital surface models and orthomosaics in Pix4D-Matic, then segmenting, classifying, and analyzing these products using geographic object-based image analysis techniques in open source R workflows and in Trimble eCognition software. And then lastly, following the drone flights, I'm collecting samples from each substrate class, which typically means combination of oyster, shell, sand, or mud. It kind of depends what exists at the site because obviously they're not all the same. And then back at the lab, I'm counting and measuring every oyster in these samples, including the little ones shown here, which is yielding size class and density data. And my hope is that by applying these values to the final classified image, I'll get some very preliminary estimates about the quantities and sizes of oysters at each site. So this project is still very much in progress, but I have included an example of one orthomosaic that I collected. And this is showing a site right near the boat launch in Shell Mound, which is in the Lower Suwannee National Wildlife Refuge. So this is the imagery after being stitched into an orthomosaic. And then this is the orthomosaic after I classified it in eCognition. So here you can see blue areas are oyster, green are shell, and tan are mud. And I'm still working on refining the classification process, but so far I'm very excited about how this is turning out. And then, as I briefly mentioned earlier, this drone imagery analysis is hinging on the GeoBia approach, which, as the name implies, differs from typical classification methods in that it considers entire objects when it classifies rather than single pixels. So people refer to it as working more like a human mind, like it sees an entire cluster of oysters rather than just one pixel in the cluster. And this sort of approach is really useful for areas like estuaries, where we all know habitat patches exist in different combinations with one another, as shown in the classified map on the left. And it's important to note that that orthomosaic on the left is on a scale about 4 times greater than mine. So kind of what I see my project doing is downscaling this approach from like the estuary level down to just an oyster habitat and considering the oysters as the patches within that site, if that makes sense. So my next step is to analyze my classified orthomosaic and again, derive many of the metrics highlighted by the mapping subcommittee. I was really happy to find this report because honestly, it organized all this information in a more concise way than I ever could have. And I'm hoping to ultimately report on each of the metrics and reef conditions that are conveniently listed here by the end of my workflow and see how these metrics then correspond with the wave energy, harvest, and freshwater drivers that I mentioned earlier. So obviously I have quite a bit of work remaining, including processing wave data, collecting remaining drone images and corresponding samples, and then putting together and analyzing the imagery. And I wanted to make an important note about my approach, which is that namely right now, unfortunately, it is not free. I am relying on a fairly expensive drone and 2 proprietary softwares, all of which are obviously barriers to entry. However, from speaking with collaborators, it does seem that open source workflows using R and QGIS and the like are very much in the making. So I expect that this approach will become more accessible with time as those open source programs catch up. And it is also important to note that although the Geobi approach does have a learning curve, which honestly I'm probably only halfway up it at this point, it does fulfill one of my big goals, which is that it is repeatable. So essentially, once you have tuned your workflow and your parameters to a given site, it is really easy to just press play on that workflow once you have new imagery, which allows those sorts of change analyses that can be really valuable. And then lastly, one cool thing is that I have found some new oysters. This image is again from a site near Shell Mound, and I learned it is actually not included in the WIMP oyster beds layer. So all of the dots and little gray patches in that yellow rectangle are oysters, all of which right now are currently flying under the radar, pun sort of intended, in terms of formal monitoring. So drone imagery is potentially another useful tool here in terms of ground truthing potential oyster habitats and maybe getting eyes on new ones that aren't inventoried yet. I have many collaborators to acknowledge on this project, as well as folks who facilitated fieldwork and many types of analyses. And I'm incredibly grateful to Florida Sea Grant, who has funded this project through their graduate student coastal and ocean fellowship. I know this was a lot of information delivered very quickly, so please feel free to send me an email with any questions or comments after the meeting.
Thanks so much, Emory. That was a lot of great information.
Sorry, it was
I really
quite a bit.
appreciate the No, it's all great. You know, it's great to see the connections too to some of the products that the FORS Oyster Monitoring Subcommittee has developed. Just to know those tools are useful in highlighting some of these potential research needs. So we'll just open it up for questions at this point. If folks want to type them in the chat or come off mute and ask Emory, that would be great. I can start us off. Emory, I think, as I said, there's some great implications here for monitoring of oysters using these technologies and understanding what these clumpy reefs look like. I know you mentioned kind of an analysis of those metrics against the amount of wave energy, the harvest, and some of the other drivers here. Have you thought it all through, or what is your sense on once that information is obtained, how a better understanding of what these reefs look like, the degree of clumpiness may influence potential restoration of some of these areas?
Yeah, I think, again, this is sort of informed by my experience in my master's. I think if it seems that there are reefs which are A, being exposed to a lot of that wave energy, and B, seem to be, this is why the need for kind of longitudinal data through time is so important, because I do think some habitats, even in their happy place, are just going to be clumpier by nature. And the key is trying to figure out, were they always like that, or has this been something that signifies a breakup over time? And if it is something that we can see through the imagery through the years that it is kind of disarticulating, then I think that speaks to a need for kind of more robust restoration methods rather than something like putting out shell. Matt and I, from our experience in North Carolina, have seen cases where you put out loose shell and all it takes is one storm and it's gone completely. And that's obviously a lot of money, a lot of labor. So there are people at UF who are working on more rugged substrate that you actually kind of anchor into the ground and stabilize the entire area. And that seems to be where my brain goes in cases where it seems like wave energy is playing a role. And again, the massive caveat to this entire presentation and project is obviously I'm not going to be able to prove any causation because this is a survey. I'm not able to control any of these things. Just because an area is closed to harvest doesn't mean harvest isn't occurring, that sort of thing. So that is a major caveat is I'm hoping to at least sort of point to the relative role of these drivers, and especially in combination with that other dissertation chapter that I mentioned, where I actually do have kind of positive evidence that this level of wave energy makes a clump that weighs this much move. So yeah, the order of how I release my data will matter here to see if I can make any sort of argument. I apologize, that was long-winding. I don't know if I
That's okay. No, that was great. Thank you. Yeah, it's exciting stuff. So we got a couple hands up. Vincent, want to go ahead?
Yeah, great presentation, Emory. And yeah, you kind of answered my a second question I had with regards to trajectory of oyster reefs, and I'm wondering if anybody in the group as a whole has observed a change in sort of state of articulation, more contiguous to clumpy reefs. Is that something that we think happens, or you were saying that, yeah, maybe some reefs are just the clumpiness is part and parcel of that reef itself, and that maybe it's starting state versus a transition from something more articulated. So I think that's a really interesting set of questions and observations. So I'm just wondering if anybody has seen that. And then the other question I had in the chat was, I noticed in the image it looks like there's some straight lines, and I'm wondering if that was what caused that, if that was some human activity.
Those are propeller scars.
Okay.
Which is insane. Yeah. I feel for the lower unit of whoever's boat that was.
Yeah.
Because there's quite a bit of airboat activity around this area, but obviously that's not evidence of an airboat. So yeah, somebody's outboard several of them had a really bad day here. But yeah, it is amazing because being on foot, like these are my ground control points. When I was going out and putting out the ground control points, you just don't really notice these at all. And or you could just tell, okay, there's not much oyster there. But yeah, when I stitched this together and looked at the output, I just went, oh my God, are you serious? Because that's a long expensive boat repair.
Yeah. And then finally, I just wanted to thank you for using the guidance document. So.
Well, I was making a slide explaining the logic behind all these things, and then I found the report and I said, oh, well, they did a better job, so I'll just use theirs.
Matt?
Thanks, Katie, and thanks, Emory, for that presentation. It's exciting to see this work being done in this region. A few things here. One, I was pretty interested in your number that those clumps, you've seen them move up to 50 meters. I'm not super surprised, but it's cool to see some numbers associated with that. So I'm definitely maybe not here on this platform, but maybe somewhere else, we could talk about that more. Um, I mean, this region is very interesting and unique with the oyster habitat, these basketball-sized clumps. It's from my experience across multiple states, it's like a new habitat that I've been exposed to, and it's kind of different from other places. So it's unique to learn more about this area because of its uniqueness. But connected to that, I'm very interested, and I don't know if it's measurable or easy to measure, but like we see these reefs, you show it in your pictures. If you go out on the water there, you see it like the gradient from these really healthy, you know, fully covered reefs. Then you see these other like it's like 10 basketball sized clumps on the reef. So like there's this gradient of continuity like you described. I'm very curious, is there a threshold in that continuity gradient where these clumps start to move around more, or the oyster densities are really starting to get impacted because of those dynamics based on energy and, you know, density and size class you said you're measuring? Like, I'm very curious, is there a threshold with that clumpiness where we really start to see the impacts of energy and nature kind of take its toll on the reefs? Um, you know, especially for long-term mapping and monitoring and understanding these reefs, like, is it a gradual thing where densities and size classes are impacted, you know, just gradually as the reef starts to get more patchy? Or is there a threshold where once that patchiness reaches a certain level, reef's gone or something of that nature? So I don't know if that's something you're looking at or trying to build into this analysis, but I guess for you and the larger group here, that would be something of interest from a research perspective.
That is something when I was in my first year, I wanted to ask that question. And essentially it became so clear that a lot of work needed to be done prior to that question. So I'm hoping that someone in a couple years after having read my paper can then do that, because I completely agree. And this is kind of, I call it one of the things that's always brought up in a discussion section of a paper. Is wave energy is always mentioned in papers that just discuss reef degradation and reef collapse. They say wave energy is probably playing a role. And what I tend to see people saying is they think in terms of that threshold, there's some, maybe it's a disturbance, like a really heavy harvesting day or a bout of disease or something that then, yes, creates an opening. And then that means kind of more persistent ambient stressors like waves start to chip away at it. Essentially, yeah, once there's one, and I think this is Peter Frederick from UF in the wildlife department. He has a paper about this, that essentially it takes kind of some sort of acute event, and then these more chronic things like wave energy can start kind of the downward slope. So I don't think wave energy is itself the thing that starts the degradation, because obviously waves are always here. Oysters have evolved to deal with them. So I think that's kind of the framework I would approach it from, is, yeah, there has to be something, which maybe that's sort of like the threshold you're talking about. There's like some threshold of stress, whatever type of stressor it is, and then the other factors acting on it kind of start the slow roll down the hill. But clearly, yeah, there's a lot of work to be done here. I would love to answer that question, but I'm not wild about the fact that this is a survey, and honestly, I fear what my statistics process is going to look like in trying to answer any of these questions. But I feel like it kind of had to be done just as a baseline data collection. So yeah, we'll see how much I regret this in a year or so when I'm trying to analyze it.
You come from a good background. You've got the experience to do it. Just a quick follow-up. Are you guys going to try and quantify density from the aerial imagery similar to what Nikki and her collaborative NEARS group is working on the East Coast.
Correct me if I'm wrong, Nikki, that's like manual delineation, right? Of the image.
Correct. Well, we're trying to use drones and then all the metrics that come from the drone imagery and combinations of different metrics, trying to compare those to, our in situ estimates of density and rugosity and size class. That's probably not going to happen, or percent cover and those types of things.
Then, yeah, it does sound similar. Poor Nikki, I was emailing her yesterday. I'll email you again.
Yeah, I'll put a link in the chat to the project.
Oh, great.
Dr. Kane has a question as well.
Hey there. Great presentation, Emory. So I just want to make sure I'm hearing things correctly. That wave energy is related to the contiguousness of intertidal reef areas. Is that what you were suggesting?
That's why I'm testing. I'm suggesting it, but I'm not necessarily convinced.
Okay. So these little clumps that are the observation point of focus here, they have different sizes. And we're assuming that those clumps are alive too, they represent live oyster, right? But of course, they may or may not. And those clumps, so I was fascinated by perhaps my misunderstanding of what the relationship could be with wave energy and contiguousness or reef continuity, which I'm assuming that's the relationship with what reef continuity means, that you've got enough contiguous live oysters that no matter what the density of those clumps was, their heterogeneity was kind of similar across densities. Like you'd think, like considering that they move around with enough wave energy, that they're not cemented down like a burr might be on part of a reef. They don't all seem to be all bunched up. You would expect that waves would move things around to a point of least energy where things would settle, and yet they're somewhat evenly dispersed. This was an observation, and that also that these clumps come from things that aren't clumps, right? So as you know, that all of the shell material that's not a clump in these analyses contain a lot of live oyster, because that's the genesis of those clumps, right? And some of those that hash material and shell material that's not part of a clump, some of them by an act of magic and a wave of a wand develop into small clumps that under certain conditions grow faster than others and get maintained in that reef regardless of the rolling around that goes on. But so I'm just sort of looking at taking all of these variables and looking at the clump genesis. Out of nothing comes a clump, right? It's because it's not out of nothing. There's a lot. There could be as much live oyster out of the clumps as there is in the clumps. It's possible,
So
right?
I actually, the clump genesis argument was one that happened for much of 2022. And again, you're all just begging me to present my entire dissertation proposal defense here. But the clump formation question, so I completely agree, as I showed in that little photograph, those tiny fragments that have beautiful spat on them. So yes, there's definitely what I call the bottom up formation. But, and again, kind of like Matt said, I think this might be fairly unique to this area, but on Corrigan's Reef, and I'm thinking of this because I should have put a photo in, there is a degrading reef that if you tap it with your foot, a clump falls off. And again, I don't have a causative way to test this, but I think non-coincidentally on Live Oak Key, which is kind of to the northeast landward of Corrigan's Reef, you have a marsh shoreline with tons of clumps in front of it. And I just don't think that that's a coincidence that Corrigan's Reef has collapsed over the past decades. And suddenly there are all these clumps right in front of the marsh where and it's mud. No one can figure out, there's not even like shell hash. So I think it's part of the question is figuring out, is it the bottom up or the top down? Because I think, as you said, if they're forming in the bottom up pathway, then that speaks to maybe actually a healthy reef and one that, yeah, through they're bucking the odds and they're actually building biomass. Whereas if it's the top down pathway, that's probably a danger sign of a reef somewhere is falling apart. So that's my thought experiment that I've gotten.
Yeah, I'm just
Sucked
thinking
into.
about it as you're talking and thinking about what little observational experience I have on the East Coast, like around where Nikki is. And that there's a lot of mud over there in between the clumps compared to around the Big Bend. I mean, not that you can't have both, but it's amazing though that just these burrs, like they're not really burrs, I guess. That's not what you call them in an intertidal scenario, but they're sort of representing like the last stand, somebody's trying to like it's not necessarily you're looking for population expansion. That's the hopes of, people that are making the observations and doing the management and like, what's the possibility of that expanding into something bigger? And so there's the concept of threshold population levels to see, and you probably know so much more about this than I do, where in subtidal situations, it appears that there is a threshold level of population density required to sustain a certain level of recruitment at all cohort levels, at all size classes, below that density threshold, recruitment is either much lower, particularly larval recruitment and survivorship from there. I'm just wondering about, how that all fits in. Maybe I'm trying to weave together intertidal and subtidal observations, and I shouldn't be here. But I'm just wondering if do you see expansion of live habitat in your observations? That's an easy question.
Yeah, obviously I've only been at these sites for a year. So I think that would be my best metric for expansion is kind of a false one, which is watching restoration substrate that we put out in 2022 get absolutely covered. And I mean, had legal oysters within a year and a half. So, but that just speaks to the fact that larvae aren't the problem in this region. There are plenty of those. It's just finding somewhere for them to go. So unfortunately, yeah, I'm not the best one to speak about expansion. And unfortunately, I've seen folks on the side in the chat mentioning speaking to local oystermen, and I absolutely agree. That's something I need to do more. But even when I was doing drone flights a few weeks ago with the captain from the UF Marine Lab, who used to be an oysterman, we went to one of my sites, which is one of my kind of degraded, in my spectrum, it's on the far right of it's essentially just shell, a few clumps. And we got out of the boat and he looked around and he said, this looks really different. This didn't look like this 5 years ago. So it is over a scale of very recent history that he said this used to be covered. So again, not speaking to loss, not really the expansion, but I off the top of my head, I think that's a byproduct of me being relatively new to the area, unfortunately. So that's a great question, though.
Thanks so much.
Yeah, there's a lot of good conversation going on in the chat and a couple resources that folks have dropped into. So for folks who aren't tracking that, check it out. Steve Durham.
Yeah, hi, thanks, Emory. I apologize, I was late to the meeting today, so I missed a bunch of your talk, but I was intrigued by an observation that you just mentioned in one of your answers where you said that there were clumps kind of along a marsh fringe.
Mm-hmm.
So am I understanding correctly that you were thinking that those clumps were essentially rolled by wave energy off the reef over to the marsh edge by like wave action?
Yep, that's my guess. Again, I'm not causative at all, but I think it's interesting that, yeah, this marsh, this substrate that is waterward of the marsh, again, is not shell hash, it's sand or mud, and it has shoot, I wish I put a photo of this. And all the clumps are, interestingly, fairly uniform. They all are, not in their size at least, but the size of the constituent oysters are all fairly uniform. And it just honestly, it jumps out at you because it doesn't look like an oyster habitat. There's no shell, there's no culch, there are no dead oysters. It's just a bunch of clumps. And if you look out into the Gulf, there's a bare shell bar. So again, I think someone dropped some aerial imagery, which I'm definitely going to look at, because I think that would be one way to verify my scheme.
Yeah.
But
well, and so what was the distance from the, just approximately? Because
so
I'm
bad
intrigued
at
by
this.
this it's an interesting potential mechanism for how in a lot of these soft sediment habitats you can get new reefs eventually, right? Kind of springing
Yeah.
up.
Yeah, and then the question is if there's how does the marsh grass feel about that? Because you can see some of it is being crushed. But yeah, it's the net gain, I suppose. Okay, I'm sorry, I'm cheating. I'm on Google Earth because I'm awful at estimating distances. Okay, so from my kind of shell bar site to the shoreline where all the clumps are, it's 0.5 kilometer.
Wow.
And again,
I
my
wonder if
theorized location it's coming from.
yeah, have you noticed just clumps that are essentially in transit, so to speak? Like, are there clumps that are also off the reef that are not up against the marsh edge, that are kind of just like out?
Yeah, like halfway
middle?
there.
Yeah.
That's a good question. I'm never there at that low a tide, because if you're there at that low a tide, that's your new home, and
Right.
you're gonna live there for the next 24 hours. But that's a really great question. I've not seen it, but you can see them kind of into the subtitle even.
Okay,
So
because
that's a great question though.
are you familiar at all with cheniers? They're like shell accumulations and stuff that I think there's some in the northern Gulf areas, and then the best known ones that I'm familiar with are in the Gulf of California. But it's amazing, if you go there, they're all mollusk shells, just like acres and acres of just ridges of mollusk shells. And during the tides, you can actually see their millennia coloradoensis, and they float like little boats. They just, when the shells die, they just, get transported on the wind into these like big dunes almost of shell. So it'd be pretty wild if some kind of similar sort of transport is going on with oyster clumps. So
yeah, and
really cool.
I don't know if you saw my introductory slide, but in one of my other dissertation chapters, I've tagged clumps and put like RFID tags on them, and then essentially let them go and checked them every week and a half. And I had one small one, which was probably about this big, and it went 60 meters. So yeah, they can go in the right. And I think part of it is once they get dislodged enough. So I think, again, I don't think wave energy is the thing that starts the process. I think wave energy kind of capitalizes on something that made the oysters less stable, if that makes sense.
Yeah, sure. I mean, if there aren't that many, I know you said you can't be there at the times when you would be able to see them, but if there aren't intermediate ones, I wonder if it's more of a acute process where, like, if there's a big storm that comes in, they all get moved kind of at once in a dramatic event, rather than it being sort of a gradual process.
That's true. And now at least I do have, I guess now I have baseline data. So if that does happen, then it's easy to fly again. So another benefit to the drone imagery is that that's a great idea. Maybe I could fly again if we have a big, knock on wood, hopefully don't, a big event.
Well, thanks for your thought-provoking
thank you.
discussion and presentation.
Yeah, I second that. Thank you so much, Emory, for joining us today. We hope we can keep you here with us going forward.
I would love to report back once I have more imagery classified. So
great. Absolutely. Thank you. Okay.
Thank you.
Are you headed in the field? I know you need to hop off, so feel free.
No, we had logistical problems, so I'll actually probably stay for a little bit.
Okay, sounds great. All right, so let me just check. Is Lauren with us via under a name or phone I don't recognize? Lauren Hinton Long. Okay. I think she was not able to join us. I haven't received a message, but what I would suggest in lieu of her presentation is if there's anybody new to FORS that would like to come off mute and introduce themselves. There's been a couple new folks added, which is great. Always great to have new folks. So anybody here that would like to do that?
I'll go first.
Hey, Josh.
Hey, Katie. Josh Mills. I work for RES, but got started with Florida Oceanographic Society with Vincent many moons ago, doing shell collection and living shorelines, primarily oyster reefs that are seagrass nursery. And so just been building on that to where I am now. So still focusing on nature-based solutions and oysters, seagrass, mangroves, all that fun stuff. But thank you for letting me be a part of this.
Welcome. And what does RES stand for, Josh? Do you mind?
Resource Environmental Solutions. So we're relatively new in Florida, maybe going on 3 years now. And so that's it's my first private sector job. So I still have a nonprofit government mentality, but I'm working on that. So
Good to have you. Thanks.
yeah, thank you.
Anybody else? Okay, I think that might be it. Before we move to open forum, I just wanted to give the steering committee a chance. Vincent, I don't know if there's any updates or big takeaways you wanted to share with this larger group today. To put you on the spot briefly.
Nothing new. I'll be sending out to the steering committee members. I'll be sending out a poll. We're going to have a steering committee meeting in September, I think was what we had discussed.
Great.
But yeah, nothing new that I can think of right now.
And welcome to Vincent as the new FORS steering committee coordinator. For those that haven't heard, Ann Birch has passed the torch. So we're happy to continue that team. Thanks, Vincent.
You're
All right,
welcome.
anybody
Thank you.
have, absolutely. Anybody have project updates, research questions they want to pitch to this group before we close? What's new and exciting in the field?
I've got one. So,
Go ahead, Nikki.
not too long ago, Jan McKinnon from Georgia's Coastal Program was down here in Northeast Florida, and you all have probably heard that Georgia has mangroves now. So we got to talking, and she was kind of asking me, like, tell me everything about, the impacts of mangrove expansion and things like that. And we got to talking about oysters and mangroves. And I know that there have been some papers, like maybe Linda Walters and Ed Profit from the Indian River Lagoon, talking about oysters on red mangrove prop roots. And I just was hoping maybe if anybody has like good papers about that topic, just in general about oyster mangrove dynamics, it's something we want to start digging into a little bit further. Because the question is, are mangroves going to start growing on oyster reefs and kind of taking them over? And if so, how will those different, habitat services change? And then there's also the fact that I've been seeing a lot of like oyster reefs growing into black mangrove pneumatophores and all of that too. And I don't remember ever seeing papers about black mangroves and oyster reefs. So yeah, just putting that out there is something that a bunch of us are going to be talking about soon, and maybe designing some monitoring or research projects around.
Actually, oh, I'm sorry, Sandra raised her hand. I'll wait.
So we have the royal we have mangroves and up here as well, Alligator Point and Ana. And actually, my grad student has an ANA fellowship, not to look at the interactions necessarily between mangroves and oysters, but looking at, mangrove invasion over time. But in terms of papers, our faculty here, Josh Breithaupt, he did his part of his postdoc was down in South Florida, where he was looking at interactions between mangroves and oyster reefs, and there is a relationship between the mangroves produce some level of acidity, which impacts the oysters. So there is that interaction. And I'm not going to embarrass myself by trying to pretend I know more than I do, which is minimal. But I can get you his papers, Nikki. And you might want to talk to Josh about it, because he's looking at the relationship up here between mangroves and oysters from that ecological perspective too. So if that's something that is interesting, I can get those for you.
Yes, please. Thank you for that.
And Sandra, if you don't mind CCing me, I'm happy to drop those on the FORS library.
Sure. Yeah, I can do that.
That would be great. Thank you. Go ahead, Josh.
Yeah, I believe it was in the pros group chat, but Savannah dropped a project in Pinellas County where they're doing oyster gabions, and then they're going to put volcanoes on top with mangrove planters. And I'm assuming as the mangroves grow, they would grow into the oyster gabion. So I don't know if that's in the same context that you were talking about, but that could be where you can start that study at the very beginning. You have your baseline now to see how that evolves. So I can find that. I believe it. I'm 99% sure it was in the pros chat that they were talking about that, but that would be the mangroves going directly into the oysters. And that I'm sure someone else is on top of it. As Savannah's the one posting that, but could be interesting.
Yeah, thank you. That's taking it to the next application level. So that's great.
Vincent?
Nikki, you might already be aware of this, but Ed Profit had a graduate student looking at, I think, some of the ecology of proper red mangrove proper oysters, and then applying that to some restoration projects using those simulated concrete seawall inserts that simulate red mangrove prop roots. And that was a number of years ago. I can't remember the student's name. But the growing of or what might be growing of oyster reefs into black mangrove pneumatophores, I think that might be pretty new, and that could be a really interesting study. I mean, I could see the pneumatophores trapping shell in the same way that we have used Spartina plantings in South Florida to help trap red mangrove propagules.
Yeah, that interaction of those two, they both seem very happy with it. It does seem like a lot of small oysters, so they're not like the typical oyster reef, like big clusters and large, fishery size oysters under the black mangroves. And maybe that's, who knows?
Might be an elevational thing because of where black mangroves can rest and what can recruit into there, and if there's any limits on their growth due to their where they are elevationally.
Yeah.
Discussion. Thanks, Nikki. Anybody else want to share an update? So I will follow up. Lauren Hinton Long, our second speaker today, many of you may recognize her name. She did a series of interviews focused on oyster habitat management and needs assessment for the state of Florida. She's a recent UF graduate. My understanding is she's doing a postdoc or some kind of postgraduate internship out in Alaska. So it's a bit early for her this morning. But I will definitely follow up and we'll try to get her back on our agenda for a presentation to this group coming up. Our next FORS meeting is October 17th. So if I haven't sent out a calendar invitation, I'll be sure to do that here shortly, and look forward to seeing many folks who maybe are in the field today back with us then. In the meantime, feel free to continue the conversation, stay in touch via email, and hope everyone has a great rest of their day today. Thanks, y'all.
Thanks so much, everyone.
Bye.
Thanks.
Bye, everybody.
Thank
Bye.
you.
Bye, everyone.
Bye, Kent.